Hi, welcome to my talk. Good morning for all those who obviously were not out drinking all last night. You make it here at 9:30 in the morning. I'm Tom, and this is my talk, Android in the Healthcare Workplace, a case study. A little bit about me. That's my name, Tom Richards. I am currently a security consultant at Cedigital. We're a sponsor here. There's my Twitter. If you feel like following me, sometimes I say something interesting. There's my personal website. Keep up to date on my projects. I have a couple offensive security certs, Security Plus and GPEN. Hacking stuff, I published a number of vulnerabilities in open source software, from SQL injection, cross-site scripting, denial of service. 18 published vulnerabilities credited to myself, and 7 of those were assigned CVEs based on what they were. I'm also a little bit of a developer. Pwnberry Pi is a Rambler script for pen testing tools for the Raspberry Pi. Who here knows about the Raspberry Pi? All right, so go look that thing up, it's fun. I forked it from Pony Express, I gotta go yell at those guys. I also wrote GooFile. It's been in Backtrack 5 since R2. It's a command line tool for looking up file extensions per domain. You feed that file extension, a domain, and it spits back the Google results, so that thing's pretty cool. All right, one important note. This talk that I'm giving is work that I've done at my previous employer. I did not do this while at Cedigital, so I am not breaking any NDAs or anything. Some of the things that I'm showing here have not been fixed yet by the vendor, so I'm blocking out IP addresses and vendor names and stuff, but for the most part, they fixed a lot of what I found. All right, so why am I giving this talk? Mobile is exploding. You know, how many people here have smartphones?
No, not at all.
And no one? Still have one of those green lit LCD phones that you gotta flip the front out on? Yep, there's always one. So companies are looking to find ways to make money on this, right? Everyone's got these, whether it's having your employees have them or deploying them to your staff to perform your business functions. So what we're seeing is people are very rapidly writing applications for this platform and making a lot of security mistakes as they're going forward, trying to get to the market first. I used to work at a home healthcare company, so think of like visiting nurses. So being in healthcare, we had to worry about patient information, patient confidentiality. We had to protect that patient health information. And what we were looking for to do is encryption. We wanted to make sure that patient information was encrypted both at rest and in transit with that application. So, like I said, I worked for a home healthcare company. We transitioned from a thick client application to a mobile application. So what the nurses would do, we had like 75% of our staff was all field. So they would go to your home, check on you, take your vitals, dress your wound, administer drugs, whatever you needed to do in the home that you were discharged from the hospital, but you still need a level of care. So to help them do their job better, we decided to go to a mobile platform. Instead of carrying a thick laptop and having to turn it on and wait, they had Samsung Galaxy Tabs. So it made their lives a lot easier. The vendor we went with, it was a new product. They had originally written it for Windows Mobile 5 and 6. And they decided to port it to Android because Windows Mobile was in a decline. Who here has a Windows 7 or 8 phone? Yep, that's why they wrote it for Android. And Apple costs too much money to develop for, so. Quick thing about deploying devices. We had 250 tablets right out of the gate, all running Freo. So the MDM solutions were just horrible. I mean, the most we could do was force a password on them and wipe them if they got stolen, if they were on at the time. There's also no imaging available for mass deploying Android, so good business idea for anyone, find a way to image Android devices, and there's a huge market for that. All right, so the software was written for Android. It's not available in the Android market. So you would have to know the company name and have the link to download. They had it just publicly accessible. You didn't have to sign in to download the APK. If you Google tar enough, you find it. But it was there. So like I said, the nurses would be out at the patient site. They would then sync the data back and forth. So they would go sync to pull down the patient information and what they were supposed to do at the patient's home, and then fill it out pretty much, just point and click, enter in what they had to. and then sync that data back. The vendor stated the data on the device was encrypted as well as in transit. They told me that they were using 128 bits of encryption when they were communicating back and forth to their servers. All right, so when I looked at this, I said, how do I know this thing is even safe? Let me find a way to compromise patient information. That was my goal. It wasn't to do a complete application assessment. I mean, I started to go down many roads until I found the endpoint, but I was looking for just compromising patient information in some way that an outside attacker could do. So to perform the assessment, I first used the Android emulator. Since I had the APK already, the emulator gave me root access to the file system. I didn't have to root a device, which my employer did not want me to do because it would avoid the warranty. So that gave me the ability to also observe the traffic in real time, just using Wireshark, capturing on my computer, watch the sync go through. And then my second step was, how do I know what I'm looking for, just in general? You know, its mobile platform is pretty new. Turns out OWASP has a mobile top 10, which is pretty accurate for what you would look for at a mobile assessment. So I use that as a starting guide to go through as I was looking at this app. All right. The first thing I noticed was there was authentication and authorization problems. So once you installed the APK, you only needed 2 pieces of information. And I'm already getting people laughing. You need the server name and the agent ID. And the agent IDs were sequential. From the time the company started, you know, it was 1, and it just kept going up. So they were up to 5 characters. So when we deployed our devices, our first 250 clinicians were all in sequence with each other. There was no way to validate an approved device from being configured. Anyone here ever administer a BlackBerry server? A lot less hands than at the last con. But when you go deploy a BlackBerry device, they often ask you to specify an activation password. So you know you put in the email address, you have to also put in an activation password so the server is waiting for you to connect, so you just can't go and hook up to someone's BlackBerry. That didn't exist in the system. So at that point I said, okay, if I find the server name and the agent ID somehow, I'd be golden. I'd be able to then step through sequentially and get all the patient information in the organization. That's what the screen looked like. So you just had to enter in the server, agent ID, and then validate. The next screen was a password screen. I don't have a screenshot of that anymore. The user's password was locally configured and stored on the device. It was in an encrypted container, and I didn't get too far into breaking that container. There was a file called like password.cf or something. I was like, okay, that's got to be the password. But it was encrypted somehow. And there was no complexity requirements. Someone could configure it for a password of 1. Luckily, we kind of kept that black magic for the clinicians, so they didn't try to reset their password. We gave them a randomly generated password to use. All right, data at rest. So the application used SQLite to store the patient information within the app container on the device. And they also had a backup of that database on the SD card. So, you know, could I just pop out an SD card and stick it in my reader and get patient information? No. Turns out the database was encrypted. I could not open it with any of the SQLite readers. I found the code, and I wish I had an older version of the APK so I could pull out the code and show you. They were using the user's password as the key to AES encrypt the database. So, okay, at least, you know, someone just popped out the SD card unless they had their password taped to the back of it, which we told them not to do. That should help a little bit, right? Data in transit. So on the first sync, no SSL. Wait, it gets better. Remember I said they've used 128 bits of encryption? I want to find what cryptographer told them what they were doing. Wait for the next slide. So they were using HTTP, making post requests to a server that was publicly accessible. And then they were getting data back. So the client would just keep posting and it would just keep feeding data back. So now I'm looking at this, all right, using web technologies, what else is going on here that they could leverage to compromise this application? Does that look okay? Can you guys see that at all? So So that was the traffic going back and forth. You could just see every sync was the same. I did this with a couple clinicians to make sure like the syncs weren't crazy per clinician, and it was the same steps going all the way through. Get a little bit of a screenshot. So that's just a post request to that Falcon mobile device handler.fal. .fal was just a rename for an ASPX page. No, ASP. They weren't even using ASPX. They were using just ASP off of Windows 2003. Yeah. So in like there was no .NET, so it was just bad. Side note: so if I went to sync1.vendor.com/Falcon, which was whatever their server was, it gave me a foreign-based login prompt to sign into the server to administer it. I was like, why is this publicly accessible? They didn't like that when I told them about that. There was also no HTTPS enabled. I tried to hit on SSL and it errored at me. So they weren't even attempting to do SSL at this point. And also, if I just went to the Sync1 vendor Falcon mobile device handler.fal, it spit back some of their custom encoding at me. So I was making GET requests to it, and it was still feeding me back information. Session handling. There was no session handling. If you looked at that post request before, there's no clicking. So the syncs were sequential. So if you just replayed it, the server would have no idea if it was talking to a device or your computer. You could just have it just sit there spitting information back at you to start making post requests. You know, if you captured a packet, it just kept spitting it back and changed the destination IP. Well, source IP, it just come back. Really bad. All right, so now the fun stuff. So there was no SSL, right? But they told us there was 128 bits of encryption. Where is that 128 bits of encryption? Well, apparently encoding now is considered encryption by their cryptographers that they hired. And it didn't take long for me to just look at their protocol and reverse engineer it and start pulling out the information I needed. Because there was some plain text available. What encryption do you guys know of that just has plain text in the strings? It was amazing. So, like I said, I needed server name and agent ID. Can anyone guess what the server name is? It's just Rochester. I don't know why the _A was there, but the server name was just Rochester. So that's just in there. No, yeah, that's encryption. That's their 128 bits of encryption. Quite amazing. Yeah. So my next step was to find the agent ID. So these are two sync strings that happened at the same period of time in the sync. And if you look, there's only one spot in these where the syncs differ. And that's those two sections right there. So I wonder what those could be. Happens to be the agent ID. So I looked at this and I tried to put this through different encoding things to see if it was base 64 or something. It was custom. I did reverse the APK and the code didn't come through as clean, so I couldn't just like make a quick function spit it out. It was really like a whole bunch of case statements to make it feed this, but I was like, all right, how am I going to break this? Oh, turns out if I take the raw hex of the packet and take those two spots that are different and convert that to decimal, it gave me the agent IDs. Don't know how. I tested this on like 5 different agent IDs to make sure I wasn't crazy and this wasn't just some coincidence. No, every time at that point in the sync, if you took out the parts that were different, I always got the agent ID. So at that point, complete compromise. Someone in a coffee shop, because we actually advised our staff at some points to go to coffee shops if they were in areas with bad cell service to be able to sync. So when they open Wi-Fi, just sitting there listening, totally compromising the application. At this point, I was proud of myself and scared at the same time. I'm going, oh my God, you know, how many federal laws are we violating right now? All right, so we notified the vendor. I wrote up a document, submitted it to them. It took 2 weeks for them to get back to us. They were at some conference, which was apparently more important than security of their application. Had a call with their CTO. They came in and said, we're sorry you had to find those issues. Sorry we had to find those issues? He said, we knew about those and they're in our development stream to release 3 quarters from now. I'll take 3 quarters from now. 3 quarters from now they were going to wait to implement these. It's like, that should have been you know, the first thing you did when you rewrote the application is enable SSL. But they were rushing to get it out really quick, so. They did fix stuff right away. The next major release, which was like 2 to 3 weeks after I submitted my report to them. I'm from New York, and so we were the first company in New York to go with this vendor, and there was another large company in New York also going to this vendor, looking to go to it, and they had the app independently tested by a company, and they came to the same conclusions that we did. So when I was on the phone with the CTO, he was like, we just received a similar report to yours. It's like, well, how many people have to tell you this before? Why didn't you just do this before you sold us? By the way, it cost us millions of dollars for this. Between all the licensing, all the host licenses and the field licenses and support and everything, sucked millions of dollars into this to not use SSL. You know, it's like one different function. Okay. So they instituted the setup codes right away. When you went to configure a device on the host end, you had to say, okay, this clinician, we're going to configure a device that would automatically generate a passcode, and we'd feed that into the app. So that was good, I guess. I didn't play with it too much after they did that to see if I could break it, because I was looking to leave the company. So the second thing they did, like several months later, was enable SSL. That was maybe 2 major releases out that they finally got around to releasing SSL. So, what can we do to protect ourselves? If I was going to go back and do this again with another company, I would ask them if they had their app assessed by a security company and ask for those reports to see what they find. Good, yeah. And if they fix any security issues that were addressed, or have the app assessed yourselves. Either by another company that specializes in it, or having your in-house guys do it. Android isn't as scary as it looks. It was very easy to just look at this and see how broken it was. And that wasn't even getting into browsing the file system. I was watching traffic. Open up Wireshark, I was watching traffic. So, look at this, because companies are selling junk. Mobile is still growing, and there isn't too many good security practices. It's like the mobile guys are making the same mistakes web guys were making 10, 15 years ago with their apps, So you got to really protect yourself too, because both us and the company rely on this until it got fixed. All right. Thank you. If you guys have any questions, I'll be around probably all day. So thanks for coming.